Okay, 2.4 is algebraic reasoning. So first we're going to start off with the algebraic properties. Of equality. So it says let A, B, and C be real numbers. So we have if A is equal to B, then A plus C is equal to B plus C. Because if A and B were already equal to each other and then I add the same number to them, they're going to remain equal. Okay, so then the next one, they all kind of follow very similarly after that. So then A minus C would be equal to B minus C. For multiplication, we have if A is equal to B, then A times C is equal to B times C. But in this case, C cannot be equal to 0 because no matter what A and B were, if I multiply them by 0, it would become 0 and they would become equal, even if they weren't equal to start off with. Okay? So then we have division. We have if A is equal to B, then A divided by C is equal to B divided by C. Again, in this case, C cannot be equal to 0 because you're not allowed to have 0 in the denominator, or divide by 0, or you get an undefined term. Okay? The next one is substitution. It is if A is equal to B, then A can be substituted for B, or you could say B can be substituted for A. In any equation or expression. Okay? And then we have the distributive property. So we have the sum, and it says that A times the quantity B plus C is equal to AB plus AC. And then the difference would be A times the quantity B minus C would be AB minus AC. Okay. All right, so then we're going to go on to example 1 and 2. So these examples are problems that you have for sure done before, way back even maybe in pre-algebra you did these, okay? So the only thing that's new now is that we're going to justify each step, okay? You're going to tell me how you got each step that as you work through this problem. So the first thing that I would do here is that I would add 4x to both sides. So that would give me 7x total. Plus 2 is equal to 23. Okay, and I did that by doing addition. Okay, it's technically the addition property of equality from up higher, but you can just write addition if you want. You don't have to write property every single time. Then I would subtract 2, so then I get 7x is equal to 21, and I got that step by doing subtraction property, and then I would divide by 7 to get that x is equal to 3, and I got that by doing division. Okay, next one, example 2. Okay, the first thing that I would do is I would distribute through. So I get negative 35w minus 40 is equal to 30. Okay, distributive. If you wrote distribution, that would be fine too. Okay, then I would add 40 to both sides to get negative 35w is equal to 70. And that was by addition. Then I would divide by negative 35. And I would get w is equal to negative 2 by division. Okay, so that's all that you need there. Now, turn the page. Moving on to the next part. Okay, this is exactly what we were just doing, but now you're going to apply it to a real life situation and a word problem. Okay, so remember with word problems, a lot of the stuff that they tell us is just filler to try to mess us up and catch us up, okay, and get us worked up about it for no reason. So just read it and think, okay, when I hear that it's going to tell me to do something, that's actually when I'm going to stop, and then I'm going to go back and figure out what it is I need to do. So it says you get a raise at your part-time job. To write your raise as a percent, use the formula P times the quantity R plus 1 equals N, where P is your previous wage, R is the percent increase as a decimal, and N is your new wage. Solve the formula for R. Okay, so all that this is telling me to do so far is I'm going to take the formula that they gave me and I'm going to solve it for R. Okay, everything else was too much information as of right now. Okay, so I'm going to take P times R plus 1 equals N, and I'm going to solve it for R. So the first thing that I need to do is I'm going to distribute P through. Okay, and if you want to write down a reason for this, you can call it given, since they gave it to us in the problem. So then I get PR plus P is equal to N. Okay, and I got that by doing the distributive property. Okay, so then I'm going to subtract P to the other side. So I get PR by itself is equal to N minus P by subtraction. Okay, and then I'm going to divide by P. Okay, and kind of something I want to note over here to the side, that this side, you can also write that as N over P minus P over P, like separate like that. Okay, and that might help you divide it out easier. Okay, you could also leave it like this if you wanted to, but I think it's easier to do it this way, so that's what I'm going to do. Okay, so then I would get R equals N over P, and then P divided by P would just be 1. And I got that by doing division. Okay, so I got it in terms of R, so I'm done there. So now I'm going to keep going. Now I start here. It says, what is your raise written as a percent when your hourly wage increases from $7.25 to $7.54 per hour? So I'm going to go back and I'm going to figure out what these things mean in my problem. So P is my previous wage. So this would be P. R is the percent increase. That's what I'm trying to find. Okay, it does say it as a decimal, so I'll worry about that later. And then N is my new wage. So this would be N right here. So if I have R, I know that's what I'm solving for. So leave it there. N is 754. P is 725. And then I'm going to subtract 1. So I'm going to take 754 divided by 725 to get 1.04. Okay, and then I subtract 1 to get 0.04. So this is as a decimal, but it says that I want my final answer as a percent. So you would move the decimal place over 2 times, or that's the same thing as multiplying it by 100. Okay, and you would get a 4% increase. Okay. Moving on, we now have the reflexive, symmetric, and transitive properties of equality. So we're going to talk about these in terms of real numbers, segment lengths, and angle measures. So first, we're just going to start with the reflexive property. When I say reflexive, I kind of think about reflection. And whenever I think of reflection, I think about a mirror. And in a mirror, there's nothing is going to change about your appearance, right? There's no filter that a mirror can give you. You're not going to magically get bigger or smaller. It is what it is, right? So kind of in the same way here, a number is just equal to itself. When I look into a mirror, I see myself. A number is equal to itself. Okay, the segment length is also equal to itself. And an angle measure, or the measure of angle A, would be equal to the measure of angle A. Now we're going to go to symmetric property. Okay, you can kind of think of lines of symmetry. Both sides look the exact same. Okay, so it would be if A is equal to B, then B is equal to A. So you're just going to flip-flop what side they're on. So for segment lengths, it would be if AB is equal to CD, then CD is equal to AB. Okay, so then it would be if the measure of angle A is equal to the measure of angle B, then the measure of angle B is equal to the measure of angle A. Okay, the transitive property, I kind of like to think about the law of syllogism for this one. Okay, and the reason why I say that is like something's going to repeat itself and you're going to get rid of it and you're going to stick the other two together, kind of like what we did with the law of syllogism. Okay, so if A is equal to B and B is equal to C, then A is equal to C. Okay, so B repeated itself, I got rid of it and stuck A and C together. So for segment lengths, if AB is equal to CD and CD is equal to EF, then AB has to also be equal to EF. Okay, last one, if the measure of angle A is equal to the measure of angle B, and the measure of angle B is equal to the measure of angle C, then the measure of angle A must also be equal to the measure of angle C. Okay, another way that if you want a really quick way to kind of remember this, you can write your properties in alphabetical order, and it kind of matches up with the number of equal signs that you see or can hear. Okay, sometimes you might have to assume there is the word equal somewhere, but there is actually 3 if you were to like look it out. Okay. Okay, so the next part says, name the property of the equality that the statement illustrates. So it says, if the measure of angle A is equal to the measure of angle B, and the measure of angle B is equal to 42, then the measure of angle A is equal to 42. So that has 3. I also noticed that I have A and then B and 42. So I see that B repeated itself, so I got rid of B and put A and 42 together. So that is the transitive property. Okay. Next one is the multiplication property of equality. So it says if the measure of angle J is equal to 30, then 2 times the measure of angle J would be equal to 60 degrees. Okay, and next one, it says to use the transitive property so that I know that something is going to repeat itself and I need to get rid of whatever that is. So it says if 3x plus y is equal to 7 and 7 is equal to 5x minus 2y, then, and so I noticed that the 7 repeated itself, so I'm going to get rid of that and then I'm going to stick the other 2 together. So I have 3x plus y is equal to 5x minus 2y. Okay. Turn the page. We have our last page here. Okay, so this next page is going to be a good indication of where this chapter is going next. Okay, so this will just give you a little preview of that. Okay, so it says you reflect the beam of light off of, or the beam of spotlight off of a mirror laying flat on a stage as shown. Determine whether the measure of angle DBA is equal to the measure of angle EBC. Okay, so this is like where this is going to be my answer. So I know that's like the last thing that I need to tell you. Okay, and whenever I have figured that out, I'm done with my problem. Okay, but I have to show all of the work leading up to that and my reasoning as to why I've been able to say those things. So I look at my directions and I don't see anything else that I can use to start. So instead, I'm going to go look at my picture and I do see something that they have given me here. So by looking at the picture, I can tell that the measure of angle 1 is equal to the measure of angle 3. And I'm just going to write given as my reason, okay, since it was shown in the picture. Okay, but eventually I know I somehow have to start talking about the angle DBA and angle EBC to eventually say that those are equal to each other. Okay, I have to figure out something about them. So if I look at DBA, I notice that it's made up of these 2 angles right here. So the measure of angle DBA is equal to the measure of angle 2 plus the measure of angle 3. Okay, and what that's called is from chapter 1, and it's called angle addition. Okay, so I see that 2 and 3, but I actually know something else about 3 as well. I know that it's the same as 1. Okay, so maybe these are both my quarterbacks, and this quarterback got hurt, so I need to take him out and put this one in his place. Okay, so then I would say that the measure of angle DBA is equal to the measure of angle 2 plus the measure of angle 1. Okay, and that is called substitution. Okay, so I think I'm stuck now here with DBA, so I'm going to stop. Maybe later I need to add something else to it, okay, if I feel like I need to. So moving on, then I'm going to go look at EBC now. So EBC, I can see, is made up of 1 and 2. So the measure of angle EBC is equal to the measure of angle 2 plus the measure of angle 1. Okay, and again, that is called angle addition. Okay, well then I notice that this repeated itself. Okay, well if it repeats itself, I can take it out and stick these two together. So the measure of angle DBA is equal to the measure of angle EBC by transitive. Okay, and that's what I wanted to figure out, so I'm done. Okay, moving on to the last one. This is very similar. This time they kind of add in some numbers, so maybe it'll make a little bit more sense to you. Okay, so it says in the diagram, the measure of angle ACB is 25 degrees. So maybe I'm going to write that in there so I can remember that. And ray CE bisects angle DCF. Okay, so I'm going to fill that in as well. Okay, so that means that these are the same. Explain how to find the measure of angle DCE. So DCE is right here. That's what I want to find out. Justify each step. So the first thing that I know is that the measure of angle ACB is 25 degrees. And that was given to me. Okay? I'm going to come back and deal with this later. Okay? I think I'm going to run with this for just a moment. So then I notice that I have this angle here and this angle are across from, or make a linear pair, I guess, with the big angle with this angle right here, which means that it's also 90 degrees. So I could say that the measure of angle DCB plus that 25 degrees would give me 90 degrees. And that is called complementary angles. Okay, so then I can figure out that the measure of angle DCB would be 65 by doing subtraction. Okay, then I notice, and it's actually drawn in here for me. I wish that they wouldn't have drawn this in here because it's not technically like given information, because there's actually a reason why those two angles are the same other than it's marked. Okay, and then the reason why is because it makes this X, which if we remember from chapter 1, those are called vertical angles. So I know that the measure of angle DCB is equal to the measure of angle GCF by vertical angles. Okay, then I know that, so then I would have to know that the measure of angle GCF is also 65, because I can see this GCB right here. Okay, there is a little bit of a gray area here, whether or not you want to use substitution to say that or transitive. Okay, since it repeats itself, you could kind of say that you get rid of it, but because of the order things are written in, maybe you could argue that it would be substitution instead. So I'll go ahead and write both of those, but if you only see one or the other, that's okay too. Okay. All right, so then, why did I write that? I didn't mean to write that. I meant to write, that's what I just wrote. I meant to write 65, sorry. Trying to talk and write at the same time. 65. There we go. Okay, so the measure of angle GCF is 65 then. So this right here is 65. But I know then that this 65 and this big angle right here okay, makes up a straight line. So the measure of angle DCF plus that 65 is equal to 180. The word that means 180 is supplementary. Okay, so then I can figure out that the measure of angle DCF would be 115 by subtraction. Okay, and then so this whole thing out here is 115, but like I've written in here, I knew that these were the same. Why? Because up here it told me that it bisects. Okay, so I know that the measure of angle DCE is equal to the measure of angle ECF by the definition of angle bisector. Okay, if you just want to write the definition of bisect, that would be okay too, but this is like the most proper way to do that. Okay, so then lastly, I can tell you that the measure of angle DCE, which is what I'm trying to find, is equal to 57.5 by division. And you're done.